Hi everybody, let me go over some of the questions from practice test 4 and preparation for your long test 4. Let's take a look at the first question here. A solution to a system of linear equations in two variables is an ordered pair that, so fill in the blanks, that A satisfies the equation in the system, satisfies both equation in the system, or does not satisfy either equations in the system. When you say solution to a system of linear equations in two variables, that means you have two equations. A solution to a system means a point that satisfies all equations in the system. So that means it is a point, an ordered pair that satisfies both equations in the system. Question number 2. Explain how to solve a system of equations using graphing. Now, to solve a system of equations using graphing, the first step is to graph the equations. So you graph the equations by graphing, and then graph both equations in the same rectangular coordinate system. Now, if the system has one solution, the coordinates of the point of intersection of the lines is the solution to the system. Question number 3. Fill in the blanks in the system below so that the resulting system is true. When solving this system of linear equations by addition method, you can eliminate x by multiplying the first equation. So you want to eliminate the x. How would you eliminate it? So you would multiply this by the opposite of the number here, because you want to make sure that they are numerically equal but opposite in sign, because you're going to add them and you want the sum to be 0. So you multiply this by -5. Now, question number 4. When solving the system of linear equations here by addition method, and we want to eliminate x, we can obtain that, or we can do that by making sure that the coefficients of this is numerically equal to the coefficient here but opposite in sign. So how do we attain that? We can attain that by multiplying the first equation, or the coefficient of x in the first equation, by 3, and then here for the second equation you multiply this by the negative of the number here. So that means by -2. In that way, you will have 6x here. That's when you multiply this by 3, and -6x here when you multiply 3x by -2. So that when you add both of these equations, the answer for these terms will be 0. The sum for the two terms will be 0. Now consider the following system. We want to solve this system here by addition method. And then we want to find the solution set. So when you solve this by addition method, you actually obtain 0 equal to 4. Okay, so if you eliminate one of the variables here, multiply this by 4 so that or -4, so that you have -24 here. And by doing so, you would also get a +20 here. So that's why when you add both sides, or when you add both of the equations, it would result to 0, 4. Now, what does that mean? So if you attain 0, 4, that means that there is no solution. Okay, the solution is an empty set. And that equation is, or that system is called an inconsistent system. And this is the case, inconsistent system. And if the system is solved by graphing, the two lines is actually parallel. The two lines are parallel. That means if the two lines are parallel, there's no solution. There's no intersection. for the system of equations. Next, for instance, when you consider the following system here and you solve this using substitution method, you obtain 12 equal to 12. What does that mean? That means that these two are equal. So that means that there are infinitely many solutions to your system. So the answer is this: you have infinitely many solutions. And then we call the system a dependent system. And when you solve the system by graphing, the two lines are actually identical. They coincide. Because there are only three possibilities. What are the three possibilities? Either the two lines intersect at one point, that is the case where you have one solution, or if they intersect at 2 points, that means that the two lines coincide because 2 points determine a line. So in that case, you have just one line. And if they don't have a solution, that means that the two lines are actually parallel. Question number 7. In this number, we are asked to solve the system by substitution. So let's go ahead and do that. So we do that by first solving for one variable in one of the equations. So say for instance here, we can solve for y here in terms of x. And how do you do that? You can do negative y equal to 12. You subtract both sides of the equation by 4x. So you have minus 4x. Then you can divide both sides of your equation by negative 1. So this becomes y equal to negative 12 plus 4x. Or that's the same as 4x minus 12. So now you have an expression for your y in terms of x. Then you go back to the first equation and substitute the expression for your y. So you have 5x plus, then you have 9. Now instead of y, you write that as 4x. You replace y by 4x minus 12. Equal to negative 67. Then you simplify. So you have 5x plus 9 times 4 is 36, 36x, minus 12 times 9. 12 times 9 is equal to 108. So minus 108, and that's negative 67. Then you combine these two. That is equal to 41x minus 108 equal to negative 67. Next, you move 108 to the other side of the equation. So you have 41x here, and then negative 67 plus 108. So combining those two gives you 41. So 41x is equal to 41. So that means x is equal to 1. So we have x is equal to 1. Then you can go back here and plug in 1 to x to solve for y. So that means y from this expression is 4 times 1 minus 12. That's equal to negative 8. So the solution here is an ordered pair. And then when you write the ordered pair, you have to write first the x coordinate, the value for x. So that is 1, negative 8. That's the solution. So you have to make sure you have to write the parentheses here because that is the notation for an ordered pair, and separate them by a comma. Write first the x coordinate followed by the y coordinate. In the next equation, or in the next system here, we are asked to solve this using addition method. So let's do addition method. Now, the addition method or elimination method. So we will have to first decide which variable we want to eliminate. I would say we will eliminate y since they're already of different signs. Okay, so to do that, my goal is to just make sure that they have the same coefficients. So how do you do that? That means I would have to multiply the first equation by 3 and the second equation by 2. That's the coefficient of y here, and the 3 here is the coefficient of y there. Then this becomes 45x minus 6y equals -6. So you multiply both sides by the same value, with the same number. And then 2 times 3x is 6x. And then 2 times 3y is 6y, positive 6y. 2 times 3 is 6. Then you can add them. That is just 0. So if you add this, that is equal to 51x. This is 0. And then you have -6 plus 6 is also 0. So you have 51x equals 0. That means x is equal to 0. So now we have a value for x. Then we can substitute this value of x to either one of the equations here. Let's pick the second equation, for instance. You have 3x plus 3y equal to 3. You can plug in x equals 0 here. So that means 3 times 0, that is just 0, plus 3y equals to 3. 3y is 3, therefore y is equal to 1 when you divide both sides of the equation by 3. So the y coordinate is 1, the x coordinate is 0. The solution set is an ordered pair. So an ordered pair, write first the x coordinate 0 and the y coordinate to be 1. That's the solution set. For the next number, you are asked to solve this system by the method of your choice. Then you just pick either substitution method or elimination method, whatever method you use. And so I'll go ahead and skip that because you already know how to do elimination or substitution method. Let's proceed to number 10. Next number, find the augmented matrix for the system. So to do that, the augmented matrix here would represent the coefficients of the variables from the system. So the first column are the coefficients of x. So you will have 6, 4, 4 here. And for the second column are the coefficients of y. So notice that you don't have a y here. That means the coefficient of y in this case is 0. And also for the third column will just be z, the coefficients of z. So how do you do that? So here you will write down all the coefficients for x here. So you have 6, 4, 4. And all the coefficients for y on the second column, that would be 5, 0, 2. So that means that here you actually have 0y. That's why that is empty. You did not write it because the coefficient is just 0. And then here you have 8, 9, 5. This is the augmented matrix for the given system. Question number 12. Using Gauss-Jordan elimination to solve the system, the matrix obtained is the matrix here. What is the solutions or the system solution set? Now, the matrix obtained here is what we call the reduced raw echelon form. That is the form when you have 1 on all entries on the main diagonal and 0 elsewhere. So if you have a matrix that looks like this, then how would you write the solution set? That means that the solution is just x is equal to 3, y is equal to 4, and z is equal to -2. So let me emphasize, that is only true if you have this reduced raw echelon form, where the main diagonal is 1 and the rest are 0. If it's not in this format, then you cannot write the solution yet. Okay, so in this particular case, the solution set is just 3, the ordered triple. The x-coordinate is 3, the y-coordinate is 4, and the z-coordinate is -2. Question number 13. We are asked to write the augmented matrix for the system of equations here. Now, first, we make sure that they're all aligned, like all the x's are aligned and all the y's are aligned and the z's are aligned. Then you input it to the elements here. So you make sure that you align them. So you have 3x minus 8y plus 9z equal to -3, and then you have 7x minus 7y. Since we don't have a z, it's safe to write that as 0z equal to 5. And then you have x. You don't have a y, so make sure to write 0y for y, and then for the coefficient of y. Then minus 6z equal to -1. Now, to write the augmented matrix, you just input the coefficients here to the matrix on the left. So you have 3, -8, 9. Second row will be 7, 7, 0. And then here you have 1, 0, -6. And these are the constants. So you have -3, 5, -1. When you check, you make sure that the first term, those are the x coefficients, the second term are the y coefficients, and the third column, not term, the third column are the z coefficients. Z coefficients are 0, 9, 0, 6, 9, 0, 6. The y coefficients are 8, -7, 8, -7. So see, 8, -7, 0, and you have 3, 7, 1, 3, 7, 1. So that's it. Question number 14. Write the system of linear equations represented by the augmented matrix to the right. Use x, y, z for the variables. So you want to know what the equation represented by the first row, the second row, and the third row. So to do that, we make sure these are, the column here are for the x, and the column here, the second column, are the coefficients for your y variable, and the third column here are the coefficients for your z variable. The last numbers here are the constants. So when you write the equation, you just say 8x 0y, no need to write that, and then 3z, so plus 3z equal to -13. For the next one, you have 0x, you don't need to write that, so you have 1y, so you have y, minus negative, so minus 3z, -3z. The constant is 14. And the last equation will be 7x, 2y, so plus 2y, plus 0z, no need to write, 0z, that's equal to 3. These are the equations represented. This is the equation represented by the third row, the equation represented by the second row, and the equation represented by the first row. Here we are asked to perform the raw operation on the given augmented matrix. You have -6r1 plus r2. What does that mean? R1 means row 1, R2 means row 2. So -6r1 means you multiply -6 to row 1, including the constants, And then you add that to the second row. So let's go ahead and do that. So your first row, you will have -6, and then -48, -6 times -5 is +30, and then +30. Then the second row, you just add to the second row. Now here the second row is 6, you add that to 6, 3, 8, 8. Then what's the result? So you have 0, -45, 38, 38. Where would you place this? You would have to place this to that row, to where you're adding it. So you're adding it to row 2. Row 2. So you will have 0, -45, 38, 38. Then the rest you just have to copy. So you have 1, 8, -5, -5. Then you have -4, 8, 8, 5. Again, you would add that to row 2, to whatever row that you find here. Question number 16. Perform each matrix operation and write the new matrix. Here we have a 4x4 matrix, an augmented matrix, and we are asked to perform the two operations here. What does that mean? That means that we're changing the third row. So you're changing this row and this row. You're changing row 3 and row 4. You're going to replace that by the operations here, by the new row after you perform the operations, the row operations here. So for row 3, so this is what you're going to replace row 3 with. You're going to replace row 3 by, you multiply -5 to row 1. So you have -5, +5, +5, -5, -5, -25. Okay, so make sure you multiply -25, -5, positive, positive, and then -5. Then you add that to row 3. This is row 3. So you have 5, 0, -4, 4, 12. So add them. 0, 5, 1, -1, and then that's -13. This would be the new row for 3. That's your new row 3. So row 3 will be 0, 5, 1, -1, -13. Now for row 4, that's the next row operation. Row 4 will be replaced by -6 R1 plus R4. That means you multiply row 1 by -6. So you have -6, +6. -6 times -1 is +6. This is -6. Then -6 times 5 is -30. Then you're going to add that to row 4. Add that to row 4. So row 4 is 6, 2, 4, 5, 7. So when you add this, you have 0, 8, 10, -1, -23. This will be your new row 4. So row 4 is 0, 8, 10, -1, -23. Now the rest, row 1 and row 2 will remain unchanged. So you just copy them. 1, -1, -1, 1, 5, 0, 1, -8, -5, 0. Next number. We are given the reduced row echelon form of a system of linear equations. So this is the given reduced row echelon form of the system of linear equation. Write the system of equations corresponding to the given matrix. Let's write the system corresponding to that given matrix. use the variable w, x, y, z, because you have 4 columns here, and then determine whether the system is consistent or inconsistent. If it is inconsistent, you give the, if it is consistent, then you give the solution. All right, so let's go ahead and write the system of equations corresponding to the given matrix here. This first column here is for the x variable, the y variable, the third is the z variable, and, oh, sorry, you have the w, x, y, z. W, x, y, z as our variables. So you have w, 1w, 0x, 0y plus 6z is equal to -4. Here you have 0w, x plus y minus 2z is equal to 3. Here you just have 0, 0. So we have the two system here. Now, this system, is this consistent or inconsistent? What do you mean by consistent or inconsistent? When you say consistent, it has solution. It has solution. If it is inconsistent, no solution. So when you say it has solution, it could be infinitely many, or it could just be a particular ordered pair. But since here we only have 3 equations, we actually have only 2 equations and 3 unknowns. So that means we have an infinitely many solution. Actually 4 unknowns. So we can have infinitely many solution. And how do you write the solution of the system? Now to write the solution, we will just have, so we know this is infinitely many solution because it has more unknowns, less equations. So we can write the solution. This is an ordered triple with w, x, y, z, such that, and then you write the equation. So you can write w in terms of z. So you have -4 minus 6z. So you will have w such that w is equal to -4 minus 6z. Then here you can solve for x. X is equal to, you transpose everything to the other side of the equation, -y plus 2z plus 3. So the other one is x is -y plus 2z plus 3, where y and z are any real numbers. Okay, that would be the solution. It has infinitely many solutions. It is a consistent system. So next number, we are to solve the system of equations using matrices. Use Gauss elimination method with back substitution. So that means we don't need to write it in reduced raw echelon form. So any matrix of this format will do. And then we'll just use backward substitution. So in other words, our goal is to be able to write the main diagonal we want to write the main diagonal to be just all equal to 1. So the entries in the main diagonal should just all be equal to 1. So we will perform row operations to obtain that. All right, so as a first step, we are going to write the augmented matrix that represents our system. So we have x, write all the coefficients of x. We have 1, 1, -5. Then followed by the coefficients of y, 4, 5, -1. And then 0, 1, -1. the constants, 0, 1, negative 41. So after we have written the augmented matrix, we will now reduce this matrix to row echelon form. So the first goal is to make this third row, first column, this number here, 0. So we would think of row operation that we can perform so that this particular entry here becomes 0. So in other words, we are going to replace R3 by some row operations. So think about it. Maybe what we can do is we can multiply this number, the second row here, by positive 5. And then so after you multiply this by positive 5, you will add that to row 3. So you add it to row 3. Then this will be the resulting matrix. So you will copy your first and second row, 1, 4, 0, 0, 1, 5, 1, 1. Then for the third row, you will replace that by this row operation here. So again, you multiply this by 5. So that means row 2 is 5 plus negative 5. That's 0. So and then 5 times 5 is 25 plus plus negative 1. So that becomes 24. And then 5 times 1 is 5 plus negative 1 is positive 4. And then 5 times 1 is 5 plus negative 41, so plus R3 plus negative 41 is negative 36. So this is now our new matrix. So now for the next goal, we want this to be 0 because we want the main diagonal to be all equal to 1. So now we want this to be equal to 0. So we would think of row operations that we can do so that this particular entry here becomes 0. So we have R2, R sub 2. So think of what would we would replace to row 2. So maybe we can just multiply the first row by negative 1. So the negative of the first row will be added to the second row. Then let's look at the resulting matrix. So we have 1. So you copy all rows that you're not replacing. So you copy the first and the third row because you're going to replace your row 2. So you have 1, 4, 0, 0. And then for the second row, you're going to negate this. So you have negative 1 plus 1 is 0. Negative 4 plus 5 is positive 1. Negative 0 plus 1 is still 1. Negative 0 plus 1 is 1. Then you copy the rest. 0, 24, 4, negative 36. Next, we want this term here to be 0. So this element needs to be 0. So what can we do? We would think of another row operation that we would use to replace row 3. We would replace row 3 by, what we can do is multiply row 2 by negative 24 and then add that here. That would result to a 0. So you have negative 24 R2 and then you add that to R3. So you have 1, 4, 0, 0. And then we're replacing R3, so we copy R2, row 2, 0, 1, 1, 1. And then for row 3, you would replace that by multiplying negative 24 to row 2. So negative 24 plus 24 is 0, so this is just 0. And then negative 24 plus 4 is negative 20. Negative 20. And then negative 24 plus negative 36 is negative 60. Then next, we want this to be equal to 1. So we're going to replace row 3 by the negative 1 over 20. So in other words, we will divide this by 1 over negative 20. So we will divide row 3 by 1 over, we will divide it by negative 20 or multiply it by negative 1 over 20. So you will have, so since we're replacing row 3, we copy row 1 and row 2. 1, 4, 0, 0, 0, 1, 1, 1. Now row 3, 0, 0, negative 20 divided by negative 20 is 1. Negative 60 times negative 1 over 20 is positive 3. So now we have the raw echelon form. So this is our resulting matrix. Then from here, we can just perform backward substitution to solve our system. From here, we can say that Z is equal to 3. So that's our resulting raw echelon. So Z is equal to 3. And then here, this equation is just equal to Y plus Z, and that's equal to 1. But Z is already equal to 3. So if Z is equal to 3, then Y plus 3 is equal to 1. That means Y is equal to negative 2. So you transpose that to the other side of the equation, or you subtract both sides of your equation by negative 3. Now the first row here would represent, this will be represented as X plus 4Y, and that's equal to 0. Now we have already the result for Y. Y is negative 2. So that means X plus 4 times negative 2, and that is equal to negative 8, is equal to 0. So from here, X is just equal to 8. So our solution is the ordered pair. So the solution here, so our solution is the ordered triple. The ordered triple, you write the X coordinate first, 8, followed by the Y coordinate, negative 2, and the Z coordinate, which is 3. So it is this ordered triple here. So for the next number, we are going to consider the following system of equations and solve this using matrices. We will use the Gaussian elimination method with backward substitution. So we would want to reduce the matrix that's representing this system here into a raw echelon using series of row operations. That means we want the main diagonal to be all equal to 1, and then the lower half of the matrix are just 0. And then we use the backward substitution. Now, to do that, we are going to first write the augmented matrix that represents the system. So to do that, we will have to make sure to write this in the right format. So the first column are the coefficients of X. So we would write this first equation here as X minus 9Y minus Z equal to negative 17. The second equation will be X minus Y plus Z equal to 7. And then the third equation is X plus Y minus Z equal to 3. Thus, the augmented matrix representing this system here is just 1, negative 9, negative 1, negative 17. So we will write down all the coefficients of the variables. 1, negative 1, 1, 7, 1, 1, negative 1, 3. Then we will perform some row operations. First, we want this corner here, this entry here, to be 0. So we will replace the third row by the following operations. We would simply just subtract the two equations. So row 2 and row 3. So in other words, we can do row 3 minus row 2. Or you can multiply row 2 by -1, add it to row 3. That's the same, it means the same thing. So since we're changing row 3, we're going to copy the first two rows. So you have 1, -9, -1, -17, and then we have 1, -1, 1, 7. Okay, so now the third row will be replaced by, just subtract R3 minus R2. So this minus this is 0. This minus this, 1 minus -1 is 2. -1 minus 1 is -2. 3 minus 7 is -4. Now, if you want to, reduce this into its lowest form, you could also do that. You can multiply, or you can divide each term here by 2. So that's like multiplying row 3 by 1/2. So in that way, you will be dealing with smaller numbers. Okay. Now, but I don't have that much space in, what I'm working right now. So I'll just, omit that process. But you can do that. So you will not be dealing with large numbers. Okay. So after this, you want this to be 0. So you want this term here to be 0. Now, we can do that by replacing R2. So you replace R2 by, maybe you can also just subtract R2 minus R1. So you have R2 minus R1. So you will replace R2 by R2 minus R1. So this minus this. So you copy first row 1, -9, -1, -17. And then you will have 1 minus 1 is 0. -1 minus 9 is +8. 1 minus -1 is +2. 7 minus -17 is +24. And then you have here 0, 2, -2, -4. Next, you want this to be 0. You want this term here to be 0. So you will replace R3. You would replace R3 by, how can I make that equal to 0? You can make that equal to 0 by, doing R2. So the row 2, you multiply row 3, this 2 here, by -4. So you multiply it by 4 and then subtract it from row 2. So it's R2 minus 4 times row 3. So see, 4 times 2 is 8 times -1. So -4 times 2 is -8. Then you add that to 8, that makes it 0. So that is what we're looking for. So if we do that, so that is replacing row 3, right? So you copy row 1 and row 2 first. So you have 1, -9, -1, and then -17, 0, 8, 2, 24, then 0, again, this becomes 0, all right, as demonstrated a while ago. So it's row to 8 minus 4. 4 times 2 is 8. So 8 minus 8 is 0. So next, it's 2 minus 4 times -2. 4 times -2 is +8. You add that here, that is 10. And then that's the same thing here. -4 times -4 is -16. You add that to R2 is equal to -16. Let's see. So that's 16 plus 24 is equal to 40. That makes it 40. Then, next step is to make this equal to 1. So to make that equal to 1, that R3 should be replaced by 1 over 10 R3. So it's just dividing everything by 10. So you have 1, negative 9, negative 1, negative 17, 0, 8, 2, 24, 0, 0, 1, 4. Then you make this equal to 1. So your R2 will just be 1/8 R2. So you have 1 minus 9 minus 1, negative 17. And then you have 0, 1. 2 divided by 8 is 1/4. And then 24 divided by 8 is 3. Then you copy the third row, 0, 0, 1, 4. Okay, so now if you go back to the choices, which one is it? So it's letter D. So this is the, that is the row echelon form of the matrix. Okay, so now we will solve the system using backward substitution. So we start here. So this means that this third row here means that Z is equal to 4. And the second row here means that Y plus Z, 1/4 Z, so Z over 4, 1/4 Z is equal to 3. But Z is already equal to 4. So that means that Y plus 1/4 times 4, that's equal to 1, is equal to 3. So Y plus 1 is equal to 3. That means Y is 2. Okay, then you would have to move the Y to the other side of the equation. Subtract both sides by 1. Okay, now, so you have Z equals 4, Y equals 2. Then we have to solve for X. So from the first equation, we will have X minus 9Y minus Z equal to negative 17. Then you will just have to plug it in. All right, so let's plug in the values we got here. We have Y equals 2 and Z equals 4. So this becomes X minus 9 times 2 minus 4 equal to negative 17. 9 times 2 is 18 minus 4. 18 minus 4 is equal to 22. 18 plus 4 is equal to 22. Now, so you have X minus 22. From here, you have X minus 22 is equal to negative 17. So therefore, X is equal to 5. So if you add both sides by 22, then X is equal to 5. So we have X equals 5, Y equals 2, and Z equal to 4. So the solution set is the ordered triple 5, 2, 4. That is the solution. For the next item here, we want to know what does this augmented matrix mean. So if you are given a matrix like this, what does that mean? So this is already in raw echelon form. This means if you have here the last term, the last line to be all zeros and except for this one. So that means 0 is equal to negative 23. Then you would ask yourself, is that true? Can 0 be equal to negative 23? Yeah, this last row here means 0 is equal to negative 23. And we know that that cannot be true. Because that is not true, that means there's no solution. Because this couldn't be true. So the answer here is no solution. Now suppose if we are given like this, a matrix that looks like this, wherein the main diagonal are all equal to 1 and the lower half or the lower part of the matrix are all 0. So this is a raw echelon form. That means that you have z equal to 7, and then you can do backward substitution to solve for the rest of the variables. So this means that there is one solution. There's one solution to the system if you're able to reduce it this way, okay, in this form. Now, what about if you have something like this? So now you're able to reduce it, but here, notice that the main diagonal are not all 0, are not all equal to 1. The last entry is 0. And also, the constant here is 0. So we have an expression that is 0 equal to 0. If we have something like that, like all the entries on the last row are 0, that means you have infinitely many solutions. This is the case where you will have infinitely many solutions. Again, take note of the difference. This is when all of the terms, all of the entries on the last row are 0. So you have a consistent system, which is a 0 equal to 0. In that case, you have infinitely many solutions. So this infinitely many solution, this one here, if it's this form, has only a unique solution. There's one solution. And in this case, where you have 0 here, but there's a constant here that is not 0, that is the case where you don't have a solution. And now, just for the sake of illustration, suppose you have this matrix here. How would you write the solution? How would you write the solution? We know you have infinitely many solutions in this case. And how would you write that infinitely many solution? So let me illustrate that to you. Okay, so here, if you are given this matrix here, you would then just write this as the second row will be y minus 12z equal to negative 8. And then your first row will be x minus y minus 7z is equal to 7. So from here, you will solve for x, you would solve for y in terms of z. So you will have y is equal to 12z minus 8. And then here, you would then have to solve for x. So from the first equation, you would solve for x, that x here in terms of y and z. So you will have x, but before that, you can replace the y here by this expression so that you would just have to write everything in terms of z. So you will have x minus, now this expression will be used to replace by y. So you have 12z minus 8 minus 7z equal to 7. Then you simplify that. So you have x minus 12z plus 8, distribute the negative sign to each term in the parentheses, minus 7z equal to 7. Now, negative 12z minus 7z is negative 19z. So x minus 19z plus 8 is equal to 7. Then you move this to the other side of the equation to solve for x. So x becomes 19z, and then you have 7 minus 8. So that's equal to negative 1. So this is now your expression for x, and this is for your y. So the solution, which is infinitely many, is the ordered pair x, where x is 19z minus 1, and then your y will be 19z, let me just write that properly. So 19z minus 1. And then the y will be 12z minus 8. And then the z is just z. This is z anywhere where z is any real number. Okay, so that's the solution. It is the set of ordered pair this, where z is a real number. So that's how you would write an infinitely, or that's how you would write the solution if it's an infinitely many solution. Now for the next equation, or the next two items here, you would just have to use Gaussian elimination method to solve for the system. Again, bear in mind, if you have something that looks like this, so for instance, this is the answer, that means there's no solution. If you have something that looks like this, that means it has an infinitely many solution. If it's like this, you still can divide both sides of the equation here by 40, so that would give you a unique solution. So it really depends on what the answer would be. So I would not do 22, 23, and 24. This is just using Gaussian elimination method.